Welcome to Educational Wealth channel. Welcome to A-Level Chemistry. In this video, I am going to discuss successive ionization energies. Successive ionization energy definition: the amount of energy required to remove electrons one by one from an atom in its gaseous state. It always increases. This table shows successive ionization energy steps, corresponding equations, and the orbitals from which electrons are removed for oxygen. For an oxygen atom with 8 electrons, there are 8 ionization energy steps, and different equations represent the different ionization process, and the electrons are removed from 3 subshells within 2 electron shells. A-level students should know the definitions of first, second, third ionization energies. First ionization energy: amount of energy required to remove 1 mole of electrons from 1 mole of gaseous atoms to form 1 mole of gaseous ions with single positive charge. This is the equation for the first ionization energy. Second ionization energy: amount of energy required to remove 1 mole of electrons from 1 mole of singly charged positive gaseous ions to form 1 mole of doubly charged positive gaseous ion. So this is the equation for the second ionization energy. Third ionization energy: amount of energy required to remove 1 mole of electrons from 1 mole of doubly charged positive gaseous ions to form 1 mole of triply charged positive gaseous ion. So this equation represents third ionization energy. Successive ionization energies increases for several reasons. One reason is increased positive charge. As each electron is removed, ion become more positively charged due to number of protons remains constant. Another reason is decreased shielding. Removing more electrons decreases the shielding, which means that the remaining electrons experience a great attraction to the nucleus. And the next reason is increased proton to electron ratio. With the fewer electrons, the ratio of protons to electrons increases, leading to a stronger attraction between the remaining electrons and the nucleus. Each successive ionization energy is higher than the previous energy, showing a pattern of gradually increasing values with some noticeable large jumps. Large jumps, these occur when an electron is removed from a new shell that is much closer to the nucleus. Successive ionization energy pattern provides the important insight into electron configuration of an atom. This graph shows successive ionization energies of oxygen. You can notice a significant jump after removal of the 6th electron. The 7th electron is removed from an inner shell which is much closer to the nucleus. Therefore, a lot of energy need to remove the 7th electron. So this graph indicates oxygen has 2 shells: inner shell, the valence shell. Study the successive ionization energy of these 3 elements. Now, element 1. You can notice a big jump of ionization energy after removal of the 2nd electron, indicating that element belongs to group 2. In element 2, there is a noticeable rise in ionization energy after removal of fourth electron, suggesting element belongs to group 4. In third element, there is a significant rise in ionization energy after removal of fifth electron. So suggesting it belongs to group 5. You can deduce the position of an element in a periodic table using a graph of its successive ionization energies. So study the graph. There is a significant rise in ionization energy after removal of third electron, because fourth electron is being removed from an inner shell. So the valence shell has 3 electrons, therefore this element belongs to group 3. This is the same graph I am referring to. According to the graph, that has 2 shells, inner shell and a valence shell. Therefore, this element belongs to period 2. So, this is the same graph I am referring to. The graph corresponds to successive ionization energies of boron. Studying at this graph, there are 2 significant energy jumps. First, second. Electrons are being removed from 3 different shells: innermost shell, second shell, and valence shell. This element belongs to period 3 of the periodic table. You can notice first 3 ionization energies are gradual. After removal of third electron, there is a first significant jump. This means that valence shell contains 3 electrons, indicating that this is a group 3 element. This pattern corresponds to ionization energies of aluminium. Thank you for taking time to watch my video. I hope you found the content helpful and informative. Don't forget to like, subscribe and share my video. See you in next video.